back to one more session of your Aldehydes, Ketones and Carboxylic acid board papers. So let us start with this board paper. So basically in your Aldehyde, Ketones and Carboxylic acid chapters, distinguishing tests are very important, right? Identification type based questions, distinguishing tests, and some, complete the following reactions are very important. So let us start with this question. So first question which you're going to solve is give the chemical test to distinguish between the following pairs, right? So what did they give us? They've given us three examples. One is propanil, propanol. I have to compare between these two. Methyl acetate and ethyl acetate. I have to compare between these two. Benzoic acid and benzaldehyde. I have to compare between these two. So let us start with the first one. So now, as soon as you get, first try to write this. Divide the page. The second one is propanol. Done. As you see, both are prop, isn't it? 3 carbon chain, but the only difference is your aldehyde group here, your ketonic group here. So right here, aldehydic group and ketonic group. So what do we know? Aldehydes always respond to which test? Whenever they say chemical test, try to write the chemical test. Tolerance test. You want to write respond to tolerance test. But here when I speak about propanol, ketones do not respond. They do not respond to tolerance test. One differentiation, it is almost the same. You've been repeating the same in all the topics. Aldehydes respond to Tollens and Felding-Silver test. Ketones do not respond. They respond to haloform test, isn't it? Right, or iodoform test. Now, here you're going to write the reaction. So, where did I do? I've done this in this particular video. So please cross check with this video. This is already written there. You have to write that reaction in this particular question. And as this shows, this is giving positive test, this is giving negative test. Your differentiation chemical reaction or chemical distinguishing test is done, right? So I can erase this. Now we're going to start with the second one. What is the second one? You have to write between methyl acetate and you have to write between ethyl acetate. Okay, what is the difference here? Earlier you had two different functional groups. One was aldehyde and ketone, but here you have both acetates, but only differences in the alkyl chain. Here you have ethyl acetate, methyl acetate, there you have ethyl acetate. Let us write the formula. Methyl acetate is this, isn't it? Methyl acetate. Let us write for ethyl acetate. This is your ethyl acetate, correct? Now, ethyl acetate. What do we do? First, to distinguish between both of them, I'm going to add a base to this, sodium hydroxide to this. So, when I add sodium hydroxide to this, what are the products formed? There is a cleavage bond here. Here also you get cations and anion. Here this dissociates in this way. Here also this dissociates in this way. Let us write minus plus your cation, anion, cation, symbol. Your cation first attacks the acetate and OH attacks this methyl group. Here the cation attacks the acetate, OH comes in, attacks it. It's the same concept everywhere, but only thing you should know where to cleave the bond. What do I get? Right? C3CONA, right? Anion and cation. So this is sodium acetate. Here what do I get? I get methanol. Which alcohol? Methanol. This is here. Okay, right. Let us write methanol. Done. What type of alcohol is this? Yes, carbon with 3 hydrogens and functional group, OH is a primary alcohol. Okay, done. Let me write here. What do I get? I get CH3COONA plus CH2OH. This is which alcohol? This is ethyl alcohol. This is also a primary alcohol. Now, what should you remember? You have to remember, again I landed up. Here I got same compound, here also same compound. But here you have to again remember in primary alcohol, the only alcohol which responds to your iodoform test is ethyl alcohol. Remember that. Your work is over almost now. So once again, among primary alcohols, the only alcohol which gives positive test with iodoform or gives positive iodoform test is ethyl alcohol. So my work is done. Now what am I going to do? I am going to show iodoform test in both. Here also I am going to show iodoform test. Why? Because this is the only alcohol. Start. What do we do for iodoform? Take this methanol. You're going to add iodine plus excess sodium hydroxide. 4 and 6. I'm going to take excess. Here also same thing. You're going to take ethanol, the only primary alcohol which will react with iodine. So I've already done a video on iodoform reaction. Please watch that. Again 4 and 6. We very well know this doesn't give or does not respond to iodoform reaction. Done. Now I have to write the products for this. Iodoform we have studied in that reaction. Iodine comes and replaces and forms an LOPPT. Yes, so let us write LOPPT of iodoform. Done. After this, it's going to form a salt, NaI, then water comes out, and yes, you have sodium formate form. This is already done in the reaction. Please practice it. This is 5 and this is also 5. Yes. So what are you finding? Because of this presence or because of the primary alcohol which shows iodoform is forming a final product of sorry, an LOPPT of iodoform. This just differentiates between methyl acetate and ethyl acetate. I'm done with this, right? Then what should I do? Let us do the next reaction. That is, this is also done. Let us do the next one. I have to differentiate between benzoic acid and benzoic acid and benzaldehyde. Right. Let us take the third one. Benzoic acid and benzaldehyde. Right. Again, this is in which group? Acidic group. Here, which is this group? Aldehydic group. So write the formula. Here again write the formula for both. Now what simple test. Whenever you see a carboxylic acid, it's easy. You can show the test with sodium bicarbonate. Easiest one. Right. Here again you're going to take NaHCO3. Sodium bicarbonate test. So what does this do? First, CO, and there's a cleavage of the bond here and here. This becomes Na plus and bicarbonate ion. This becomes carboxylate or your CO minus ion and H plus, right? So what do you get? This Na comes out with this. So I get sodium benzoate, correct? Now what else is left? You have water and your carbon dioxide. That's it. Yeah, done. Here when I take, observe here, you have your, or there's a cleavage of the bond between COO and H plus, correct? Here do you have any chance or probability of cleaving into a cation and anion? No, because the functional group is directly attached to the benzene ring. So this is no reaction. So this test easily differs or differentiates between acid benzoic acid and benzaldehyde.